y-intercept. I plug a 0 in for x. I get 3, 0 squared minus 12, 0. That's going to make a 0 in the numerator. 0 over 3 is 0. My y-intercept is the point 0, 0, right at the origin. Next I do horizontal asymptote. This is exponents are the same situation, since 2 and 2 are the highest powers. So I'm going to divide coefficients. My horizontal asymptote is going to be y equals 3 over 1. Y equals 3. Next I factor. Next I look at the domain. The domain is going to come from looking at my excluded values. The domain is x, set of x such that x is not 3 and x is not negative 1. Interval notation, I would have everything up from negative infinity all the way up until negative 1. That's the first thing that it can't be. Everything from negative 1 until 3, that's the second thing it can't be. And then after 3, I'm in the clear. Everything up to infinity. Next I do canceling. Nothing to cancel. Then I do holes. Holes come from the things that cancel. Nothing canceled, so there's no holes. Vertical asymptote. Vertical asymptote are the things that didn't cancel, the excluded values that after canceling stuck around. I did all the canceling in the world, none. And 3 and negative 1 are still excluded values, so x equals 3, x equals negative 1 are my vertical asymptotes. Last, I do x-intercepts. X-intercepts are zeros of the numerator, which in this case are 0 and 4. So I have an x-intercept at 0, 0 and 4, 0. I'm ready to throw on the parts of this that I can graph. I can graph to the right of the second vertical asymptote. I have to be close to the vertical asymptote, hit the point, close to the horizontal asymptote. In between, I'm not sure what it's doing. Maybe it's doing one of these, or maybe it's doing one of these, or maybe it's doing one of these. I don't know. It's easier if I just get a few more points. I'll be more confident then. I'll plug in some points. If x is 2, then y is, and I can plug into here or here to get it. I'm going to plug into this one. If x is 2, then y is 3 times 2 times 2 minus 4 over 2 minus 3 times 2 plus 1. Looks like it comes out to 4. The point 24 has to be on my graph. So the piece in the middle of the vertical asymptotes probably looks something like this, where it gets close to both vertical asymptotes and hits the 2 points that I know are in the middle. Now I'm going to plug in a point to the left of the leftmost vertical asymptote. Maybe I plug in negative 2. If I plug negative 2 in, I get y equals 3 times negative 2 times negative 2 minus 4 over negative 2 minus 3 times negative 2 plus 1. It looks like I get 36 over 5. 36 over 5 is a little bit more than 7, so I have the point negative 2, 7-ish on my graph. So the piece on the left part of my graph must be close to the vertical asymptote, hit this point, close to the horizontal asymptote. My range in this case is going to be all real numbers because every single y value is represented on the graph. Every y value that I look, if I run a horizontal line through it, I always hit the graph, including at my horizontal asymptote because this middle piece has that y value. So my range is all real numbers, everything from negative infinity up to infinity.